Take the power of crowdsourcing, add AI into the mix, and the options become endless. Welcome to the Bridging the Gap podcast. I'm your host, Todd Wyant. This is the show where we empower you to transform industries by championing innovation. You're invited to join my mission to embrace and share the innovations transforming the AEC, MEP, and manufacturing industries. If you like our show and you want to know more, check out our new website, bridgingthegappod.com. And please share with your friends and coworkers while leaving us a 5-star review on iTunes, Spotify, Stitcher, or wherever you listen to podcasts. Today, I'm excited to welcome back Christopher Riddell, a senior solution specialist and experienced BIM manager at Applied Software. He is also the host of our sister podcast, the AEC Disruptors. Welcome back to the show, Christopher.
Thanks, man. Glad to be here.
Yeah. So would love to start with just what does good design mean to you?
You know, I would say good design is responsible. When we design anything, whether it's a product or a building, we need to think about who's using it. Especially nowadays, responsibility may be in terms of sustainability. I think it needs to solve a problem. So, you know, good design solves a problem, and it's honest. So I'm a firm believer in the form follows function, which is a term in architecture where the function of the building really designs the building, the exterior. And I was actually looking up, and Steve Jobs once said that it's not so much about what it looks like, but how it works. So I would say that's kind of what I would believe good design is.
Gotcha. So we've heard that, you know, the line data is king, but what about the difference between simply just making data and then being able to use and leverage that data? Yeah,
so we're sort of in a sea of data, right? You hear the term big data now, so there's abundance of data out there. But data is meaningless if you don't do anything with it. And so, yeah, data is king, but if we don't understand how to analyze it, how to use it to forecast, predict, then all we have is just a lot of stuff to sift through. So I think it's even more overwhelming now because of the ability to pull all this data together. And so what we're going to find in any industry is the people who are most successful are going to be the ones that can synthesize all of that data and be able to predict, determine outcomes, and sort of use it in that advantage.
So using that as kind of a jumping off point, one of the big new buzzwords is around generative design. What does that mean from a high level?
I would say generative design, think of it as co-design. Okay, so you as the designer are working with a computer. Okay. So in the old way, you would have your brain power and you could use maybe a computer, but you'd have limited design options that you could kind of come up with. With generative design, what happens is you have but then you include AI algorithms, cloud computing, and we're able to allow the computer to synthesize and optimize and create thousands of options. So fundamentally, when somebody says, hey, what is generative design? It's co-design. It's a human designing with a computer, and both are doing what they do really well. A human setting constraints and the computer running through algorithms.
Gotcha, so forming kind of that partnership instead of outsourcing it all to
partnership with the machine.
Nice. So I was reading about a new kind of cool innovative project that Elliman Architects out in Seattle was doing. And they were designing this new concert hall for the Boxman School of Music out in the University of Iowa. And it needed to perform seamlessly for all the acoustic and be a reflector of light and air distributor, and then be a cool architectural piece. So, you know, no small task there. They put a lot on this project, but they use generative design to be able to come up with different options. Do you see generative design as something being used more on like a really specific project like that, or a full scale from A to Z designing the project?
I think both, because it has its advantages. So anytime you want to optimize a solution or sift through a bunch of options, there's going to be a play for generative design. In that one, they were able to sort of dissect their building into a bunch of parts. So they maybe only focused on the ceiling, or they only focused on the exterior, or they only focused on something else. So getting all of those pieces solved generative design is perfect for that. But then we'll see where we could start in that early schematic, but you might go all the way through into manufacturing. So it could really go the life cycle of a project, not just for one specific instance. And I've even seen examples on large scales, like a city block, where if you're a developer and you say, hey, this is my program, what is going to increase my ROI? I want to know exactly what is the optimal layout here. So I think there's no too small of a project, but there's also no too big of a project either.
Interesting. Very cool. So Christopher, can you speak to the programming evolution that kind of gave way to generative design?
Yeah, and at least for this conversation, I might speak more from the AEC perspective of the programming. But what we saw happen was there was a lot of people in the very beginning of Revit would use C#, which was a programming language, and they'd use it to create add-ins and stuff like that, so they could expedite some workflows. You might be a batch print button or something you would see on a ribbon. Then what has started to happen with the evolution of things like Dynamo and Grasshopper, these two visual programming languages, we started to give way to the masses a little bit. So now common people like me could now understand the computer programming aspect of it. We could dig into the API of something like Revit or Rhino, and we could start to design that way. After we got past that part, so now we've gone from being able to create add-ins that only computer science people can, to creating visual programming that something like I could do. Now we're looking at the generative design part that actually taps into the visual programming part. And so, at least from the AEC perspective, that's sort of the evolution, is it's gone from a very hard-coded computer science type of workflow, a little easier for the common man, and then now moving into generative design that kind of builds on the other.
So becoming more user-friendly as we go along here.
It really is, because, I mean, when you think of visual programming, computer programming, it's kind of scary to think about, even more scary to try to do, but we're trying to make it user-friendly, so it's not just like the elite 10% have the ability to do generative design, and really everyone would have access.
Nice, cool. So I read a quote from Stan Allen, who was an architect. He was also the former dean of Princeton University Architecture School, and he once compared the digital and computational by explaining that digital is a state of being, it's a condition, but then on the computational side, it's an active process. So it seems like, kind of thinking through generative design, it would be most helpful to think of it as that active process. And so my question, how should you go about mapping out and defining the goals of a project before using generative design process?
You did your homework. Are you sure you don't?
It's an interesting topic.
Should I interview
cool.
you? Why am I the one answering the question? So process, right? Generative design is fundamentally an iterative process. So we allow the computer algorithms to run through and do what they do best, but there's still going to be that time where you as an individual are going to have to go through and iterate through those options. So it's still a process. When it comes to mapping that out, the only way you can get to the generative design part, to all those different design options, is you as the user have to be able to sort of create some constraints or rules. So you really have to think about the end goal. You can't just start with generative design. You have to say, okay, what am I trying to achieve? How am I going to get there? These are the things that I'm going to establish to do that. And then as you go, because it's an iterative process, it's never stagnant. You're always kind of going and checking against metrics or trying to optimize something. So yeah, it's not just you do it once and it's done, but if you don't set that solid foundation in the beginning of what you're trying to get to or what you're trying to achieve, there's no way you'll even be able to figure out the design options, because it's co-designed for a reason. We have to give the computer something. If we don't, it won't run.
Sure.
And I think that's kind of where he would be getting at, is with that is it's never stagnant, and you have to sort of do your homework, put it in the beginning, and then you kind of let it do its thing.
Yeah, so start with the end in mind and then work backwards.
Yeah, and like whenever we do Dynamo graphs or training or anything, you always start with the end in mind, because when you look at that last piece, whatever you're trying to do, a wall for instance, you would have never known that you would have started way down the line with a point. You know, unless you did it a lot, you just wouldn't know to do that. So we even talk in that sense to start with the end and think back and sort of, de-engineer it and say, okay, well, what am I trying to achieve? This is what I'm trying to do. How am I going to do that? Just like we would do for any goals in life. What's my goal? And then backtrack. How am I gonna get there?
Yeah. So with thinking of the end in mind, it kind of shifts the paradigm to be really trying to figure out how to solve the problem instead of the tool and figuring out the tool. How do you go about this mind shift in the industry?
You know, you sent me an article that I think had a great analogy where it talked about GPS. And with the GPS anymore, we kind of let it dictate, whether we use Waze or maps, whatever we want. We kind of let it dictate the route for us. We don't think about how that works. We just care about driving, and that's the fundamental thing we're focused on. Right. So like I recently this weekend went to Gatlinburg with my wife, and I didn't care how I got there. I punched in the address, and as long as I got there, that's all that mattered to me. Right. So I had two constraints: destination and as soon as possible. How I got there didn't matter. And so I just kind of blindly followed it. And so because not trying to master the tool, if I was trying to master the GPS, I want to dictate how I got there. So for generative design, it's a similar thing. Let generative design, those algorithms, that computer, whatever you're using, do what it does best. And you focus on whatever the problem is. So like we were just saying, you need to know what you're trying to achieve. If I'm trying to achieve creating 1,000 design options of a floor plan, I don't really care about mastering how it got there. All I want to be able to say is, I need to have this program, I need these rooms to be near each other, I have proximity things that I'm looking for, noise things, and that's what I do best, is figuring out those constraints and rules, and then let it do what it needs to do. So you really don't need to master the tool, because you just need to master what the problem is you're trying to solve.
Gotcha. So you touched on this a little bit, but want to dive into it a bit more. So architects are known as more the creative types, but with generative design, working with the computers more and kind of getting into the nitty-gritty of the programming, does it take a creative architect and make them more programmer-based?
I would say no. And the reason I would say no is, I mean, fundamentally you may want to say, yeah, of course you have to think like a programmer now. But if we think about what is it asking of us? As a designer, it's asking me for a set of rules or constraints. When I design any space, so say I'm working in a hospital. There are specific building codes and ADA guidelines. There are prescriptive methods to even saying that this corridor needs to be 8 feet clear. So there's already rules and constraints that I'm already designing to. If I'm designing a senior living, I may want to be thinking about, is this resident room in close proximity to this dining hall? I don't want noise to transmit back and forth. As any designer, that's working in a floor plan, they always typically start with adjacency bubble diagrams. So we're thinking about those connections. Gotcha. And so intuitively, we're already thinking about it. What generative design is asking us to do is just document it. And so I would say that it's really not changing the way we think, because I'm already thinking about this corridor has to be this wide, these things need to be near each other, and this thing needs to be further away from this because of noise. All I'm doing now is documenting what I already knew in my head so that the algorithm could recognize those constraints and sort of push forward. Gotcha. So I really don't think it's a hard mental shift, because we're already doing it. We just need to document it.
Yeah, so you say it's not changing the way you think. Is it changing kind of the timing of when you think about certain things then?
It should. I mean, again, like a really experienced senior designer, they kind of already know all of those things that we just talked about. A less experienced designer, perhaps I would start laying out something and then go back to the code and look at all the constraints and do my code research and then start to massage and fix stuff. So it depends on the experience level. But I do think, it does shift. Now in the very beginning, I got to think about, okay, what am I trying to achieve? I need to do this, this, and this. All right, how am I going to do that? I want it to optimize this number and look at this number and do this. So it does sort of shift that thinking forward.
Gotcha. So with generative design, how does that play in with better open collaboration between all the architects, the engineers, even the construction, and going on into the trades?
Well, first off, it should create more time to focus on the bigger problem. Because what we could do is we can expedite some of that time it takes to think through options and whatnot. So we should be getting to a better solution. So overall, we should be getting to a better project. I've actually read examples of like a contractor that could create graphs to do certain things that they could then feed that upstream to, say, the architect. So the architect would then be able to run these analysis to look for constructability. Is what I'm doing actually going to be able to be built the way that I want it to be done? So we could effectively create theoretically cheaper projects in the sense that we don't have that value engineering exercise, because as an architect, I used the expertise of someone else, say the contractor, on how he or she's going to design something or build something, and I can design with that in mind. So I think those are the areas that we increase the collaboration. Is one, we're just going to get a better product, but we're having more time to collaborate. We're being able to tap into the expertise of other disciplines and really use their expertise, but it makes it more repeatable.
Gotcha. Cool. What do you see as the main driving factor in this push to generative design?
Honestly, I think part of it's keeping up with the Joneses. I mean, it's like the shiny new toy, right? And in doing so, as more people push for it, there's also a push for speed. And so everyone expects things faster. We live in a society of instant gratification. So I want more designs faster, and the more owners hear about it, they know to ask for it. And so I think it's a lot of things. I think fundamentally it's going to be speed and keeping up, because what will happen is there are going to be people that become really good at it, and they're just going to crank out really good designs over and over and over, and theoretically be able to do more work. I'm not sure if that's going to happen or not, but they will surpass some of the others that are just kind of laggards, because the owner is going to say, oh, well, I want 1,000 options, I want the best option, so you as the architect, you do this, I'm going to go with you versus me who doesn't.
So with all those options, you can get hundreds, thousands of different things coming back at you. Where do you even start to analyze those options? It seems like it could get so overwhelming.
I don't know, honestly. I think it would be overwhelming. I think what you do is you have to prioritize what's important to you. So whenever we do any of these generative design iterations, there's some restriction, some constraint that's driving what it does, okay? So that may be adjacency, that may be noise, that may be code related, and so the computer will help tailor that down first off, and then I have to be able to decide what was the most critical for me. Is it a low proximity score? Is that what I really care about for this project? Maybe it's a hospital and noise, that we don't want to have a lot of noise. We have like HIPAA things and privacy and all of this stuff, so we need to be able to contain that noise, and conversations can't travel. So if that's really important, then what I'm able to do is I'm able to, whatever I'm using to get to that solution, I can tailor it to focus more on the noise component.
Gotcha.
You still may be able to tailor it from 1,000 to 100, but fundamentally there's still a human aspect to it too. I'm going to choose what I think is best. So what it did was, instead of me only being able to conceptualize 3 options, we've been able to conceptualize 100 options, but I'm still the one that's going to ultimately decide that this was the best solution for us. So it doesn't completely take me out of it, but I think prioritizing what's important is really the only way to sift through all that extra noise.
So looking at it from a production point of view for the architect, if you give 100 hours to 2 different architects, one's using generative design, one's not, how does that change the process for those architects? Is one able simply to do twice as much work because they're using generative design, or unpack that for me?
I don't think so. I think what we'll see what happens, it's no different than just at work. If you finish a task really fast, all that happens is you end up with another task. So you're never catching up. And then at the same time, with all of the options, so we're using generative design, I may have 100 hours to work on it, so I may get 1,000 options in 2 hours, but then I spend 98 hours analyzing those 2 options and figuring out what I want to do. Whittling it down to an optimal one. The other designer is going to use 98 hours to come up with an option, and then 2 hours to optimize the option. So I think there are going to be some that are just going to crank out a bunch of stuff. And so, but I think the common person, I think what's going to happen is they're either just they're not going to get more solutions, because ultimately the end goal was a floor plan or a building, a project, and so it doesn't matter how much time you give someone, they're going to use up the time. And so I think there will be some superstars out there that will use it to enhance their business, and it becomes something that's a value proposition to the people they work with. Hey, we're going to get you 10 options, and we're going to do it twice as fast, and this, that, and the other. However, I don't see it. I think those will be the few more than the everyone else, at least in the beginning, because what's going to happen is people are going to spend 98 hours just figuring it out.
Sure.
Yeah.
So that makes sense.
I don't think it's going to change it a whole lot.
Interesting. So one of the things that is intriguing to me about generative design is kind of this chance to break free of the conventional means and designs that have been used in the past. Do you get the sense from architects that this is it exciting, or is it an apprehension going on about this?
I would say both. There's going to be an apprehension from there's a lot of architects out there that are nervous about the concept of means and methods, because I'm now dipping my toes into the construction world. And by me dictating how they do something, I'm taking on potentially liability that I never should be taking on. So I think there's going to be a lot of people that just that alone kind of get, well, I don't want to dictate how they built this. I don't really even care how they do it. I just want to be able to tell them what I want and they figure it out. I think if you use it right, it can be a friend, and you can use it to your advantage. So I think there are a lot, they may be apprehensive in the sense of, okay, well, how's this going to increase my liability? Am I going to spend more time? What am I going to do with all these options? But if we think about what we're actually trying to do, what it's trying to do is create an optimal solution for whatever the problem is. That's all it is. So whether it's we're designing a building and we want to goes back to being responsible and honest. If we want an optimal project that checks 10 boxes, that's sustainable or responsible or makes the world better, whatever it is, has a positive impact, that's the end goal. So we shouldn't be afraid of a tool that helps us get there.
Sure.
But I do think there will be some apprehension in the sense of, well, I don't really want to dictate what you're going to do. And that goes to just collaboration in general, why we still are a little hesitant because of liability,
Yeah. Do you see a generational divide on that excitement versus apprehension there?
Yeah, probably. How can I say this without offending someone? I always get excited by technology.
Yeah.
But I've also never been sued before. So if there's a senior person that's been involved in a lawsuit, or they know more about how that actually could go down, of course they'll be more apprehensive. I think the more senior professionals, this is newer technology that it's just something else for them to have to kind of figure out. But there's also some senior professionals that they may not necessarily have to do this part. The generative design part may be the younger professionals that are really in the model and working on it. Maybe there's a senior designer that him and I or her and I are working together and really going through it. But I would say there probably is a little hesitation on the senior experienced aspect of it, just because they've seen more.
Yeah. But it sounds like you need their input and their knowledge.
You do, because in a way, it's the perfect team. It's like anything else with Revit or any of these other things, is if you're the senior professional, you're helping provide me with the constraints and rules. Right. I might be the one that's actually manipulating the software, but I'm relying on, before we said it was intuitive, it was in your head, I just need you to tell me it so I can write it down. And in a way, we might find that even those conversations start to help push knowledge downstream, because before I may not have ever been able to tap into what you think, and now I have the opportunity to do that because I need those rules, I need those constraints so that we can get to our end goal. And so it's not so much intuitive to you, it's something you're sharing.
So you set me up perfect for my next question.
It's like I knew what the question was.
So it sounds like you're able to really take that real world knowledge, that experience, and memorialize that that expertise, which would only heighten the ability to do really cool things on the project and kind of push the design boundaries further.
Yep.
Am I reading that correctly, or how should the industry look at generative design, friend or foe, with all that in mind?
Yeah, no, I think that's a good way to look at it, is if we can create these algorithms that think like a human, we can start to replicate a little bit that same behavior. And so now we have this expert designer, and we just love, I've learned the most from designers or whoever, when we sit down together and they talk through their thought process. I'm drawing this here because of this, this, and this. Or I would do something and their response would be, well, did you think about this over here? And let me tell you why I would have done that.
Yeah.
So But that doesn't happen all the time, and not everyone gets the benefit of having that type of relationship. So by memorializing the expertise, we really would, in a way, capture some of what that individual would have told me, and can replicate that. So it'd be like the closest thing to cloning that person. I can now think like them to some degree. It would never be the same. I mean, obviously we can't replace people.
Sure.
But if all of a sudden I knew that there was 5 things I should look for every time I design a floor plan, and the guy I was working with would teach me these 5 things, I could put those as my 5 rules, and then all I have to do is tweak those. More importantly, if it's designed in a way I could give it to you, and you may not necessarily what 5 rules that needed to be addressed, but now it's there, and you say, oh, okay, I didn't know I needed to think about clearance of a corridor. Now I do, and this is what I need it to be. And so, I think it should be friend. I mean, we should never be scared of technology. It's only there to enhance us. And I always say all the time, I mean, technology is really, I'll never propose technology as a solution to any problem, because I think there are effective ways that you fundamentally need to understand the problem before you get there. And same thing for generative design. Before I can start playing with the technology, I need to know what I'm trying to do.
Right. So shifting focus into the construction part of generative design, how can a construction site kind of optimize their strategy for assembling a building?
You know, that one's kind of interesting, and it kind of goes to memorializing a little bit, because I'm in a way, I could capture how maybe the optimal way of putting up a concrete building, and I can replicate it and make it repeatable. So we would be able to sort of analyze and figure out what is the best solution. Todd he is the best at putting up tilt-up concrete, and this is the way he goes about doing that. We can optimize how that works, and then we can now pass it on to Alyssa or Christopher, whoever, so they could follow your methodology. There's also an area in which you could almost do scenarios in how you would construct something. So, you know, maybe I'm trying to decide how I'm going to do the trusses or put up the trusses of Mercedes-Benz Stadium here in Atlanta. And I needed to think through the staging process. Well, it would have been really expensive to figure all that out in the field. Well, potentially I could use generative design to run through options to optimize based on your experience and come up, okay, what is the optimal solution for putting this together? We can create virtually free scenarios because it's all virtual, and I can then start to think about, okay, well, if I layer this first and then do this, and then I can put this up under it, it supports all of these things, and I think that's where we'll see opportunities. And so it's going to really be, whether it's analyzing the staging of how to do something, how to build up a building, or memorializing how it was done to begin with. I think those will be aspects in the construction industry. Gotcha.
So it helps to verify your game plan before you have to do anything.
Yeah, I mean, and it's no different than BIM modeling that we do all the time. You know, we build it virtually before we get into the field because it's cheaper that way. It's just taking it to that next step. So now I can start to really dive into, you know, how am I going to put this together, because it's really complicated. And is there an optimal solution that maybe can expedite my time, potentially reduce material, you know, those kind of things.
Yeah, interesting. So I want to talk about Autodesk's Project Refinery.
Okay.
So first, kind of what is that, and then what lessons can we learn from that?
So Project Refinery is really Autodesk's take on generative design.
Okay.
And it's still in beta, so I mean, half the time I struggle getting it to do what I want it to do. But ultimately what it is it uses Dynamo as its programming language.
Okay.
And so what I'm able to do is I'm able to, in Dynamo, create a graph to do something. So for instance, I was making one to lay out just a floor plan. It would pull information in from Excel, it would create bubbles, and it would position them based on adjacencies and noise, kind of things we talked about. All you would do is you build your graph to be able to do it once. Once you get it to do it once, you just need to make sure you have some metrics in there to track. So you could create a proximity score, or a noise score, or adjacency score. Once you're done with that, you can take it into Refinery, which is really a web-based platform, and what you're able to do is you can run your graphs there. And so you can choose to optimize a number, minimize a number, maximize a number, whatever you want to choose based on the inputs we created in Dynamo.
Okay.
And then you get all your options, and you have thousands of options, and it creates all the different versions, and you can sort by what has the lowest proximity score, what has the lowest adjacency, whatever was important to me. There's graphs that we can look at, there's different metrics so you can determine what is the optimal solution. Once you figure out the optimal solution in Refinery, you can push it, whatever it decides, push it back to Dynamo. So now Dynamo knows these inputs were the optimal solution, and then from Dynamo you can push it into Revit if we were actually creating a space.
Gotcha.
So it's kind of this workflow of build it once in Dynamo, make sure it works, pass it off to your team. They can use Refinery to create studies and tests and optimize. Once you figure out that perfect solution, it goes back to Dynamo and then into Revit.
Gotcha. Cool. Switching focus, putting the spotlight on manufacturing, I would assume generative design would allow for faster prototyping and really reduce the time to market. Can you speak to some of these benefits?
Yeah, so on the manufacturing side, I think where it's used the most is what's called topology optimization.
Okay.
And so what that is imagine taking a solid block that needs to be able to support 20 pounds. And what happens during topology optimization is we analyze that and figure out how much material can we take away from the solid block to reduce the weight but maintain the strength. So with generative design, we can create thousands of options to figure out what is the optimal solution for what this block needs to be, because it doesn't need all this material. It only needs a certain amount of material in certain places. So that's one application. What that does is it reduces cost, material, manufacturing time, development time, so they are able to go to market faster. Other opportunities or solutions is in combining parts. So, my human brain may only be able to think about that I need these 4 parts to do this one thing. I can optimize it, maybe it's for supporting something, and I can run it through an algorithm, and maybe it determines that I didn't need 4, I really needed 2 if I placed them in these locations, and there again we're reducing costs. So there's a huge driver on the cost side, but with all of those there's also the speed aspect, because now my product's lighter, less material, I got it to you faster, I now know I need 2 versus 1, and so I think there's a lot of opportunities there, and then just coming up with different designs of products, right? So if we work for a car factory or a manufacturer, they could use it just to look at what is the optimal exterior design for wind. And so there is a design component outside of just how can I reduce the material or the cost.
So you touched on some examples there, but do you know of any kind of cool examples in the manufacturing space?
One thing I saw that was cool was Airbus. Okay. So what Airbus did, and I don't know if I've ever seen an Airbus, but they used a generative design process to redesign the interior partition, how they sort of partitioned off the different sections. And what they were able to do is reduce the overall weight based on whatever the optimal solution was by 45%. Now, what that actually did was that equated to around hundreds of thousands of jet fuel. They saved jet fuel, and then hundreds of thousands of CO2 emissions were reduced. Oh, wow. Which was the equivalent of about 100,000 cars being taken off the road for a year.
Wow.
And they did that with generative design. So they were able to optimize, how much, what do I need where, what's the size. Under Armour uses it for shoe design, because what they're able to do using that topology optimization is they can look at the sole of your shoe and determine how much material do we actually need, how do we make a lighter shoe that's more flexible, and they can just run through iterations and options. I've seen examples of the cars. I read something about General Motors even used it for a seatbelt. The seatbelt buckle that could be 20 times stronger and 40% less material. Just simply by running it through an algorithm and being able to identify what are we trying to solve. Well, this seatbelt needs to be able to do this and this. Does it really need as much material as we're putting into it? So those are a few. And then again, you always have the car designs and all that other cool stuff.
Yeah, nice. So with generative design, how does that bring a closer partnership between architects and the manufacturer?
I think it may go to that memorializing the expertise. You can imagine if if a contractor could do it, what if a manufacturer was able to design certain type of algorithms that we could use and push that upstream? So if we're doing some sort of modular construction project where I need somebody to do the prefab at the very end, if I get their logic, so now I can kind of think like them as a designer. And so I can use their solutions to ultimately try to get to where we're trying to go. So for instance, a good example would be if we were laying out a floor plan and I wanted to optimize the number of panels we use. I could, if they created one that they use, if the manufacturer that we're using has this optimization, generative design, graphs, whatever you want to call it, if they push that upstream, I can now run that through my floor plan, whatever I'm doing, and I can optimize the layout. And it might be something as simple as move that wall 6 inches to the left, and that's one whole panel, or move it in 1 foot, and that's half a panel. So I think that's how we can start to bridge the gap between the architect and the manufacturer, is now I can start to think a little bit like them, and they don't have to redo it when they get to it. So they're going to get a solution that they know without me having to go through all this strenuous activity that's 2 panels and that's 1 panel and that's a half a panel. Yeah.
Interesting. So tell us about the AEC Disruptors Podcast. Where can people find you?
Yes, so the AEC Disruptors Podcast can be found on iTunes, Spotify, Stitcher. I think young people listen to that. Really wherever we can find podcasts. The idea is similar to Bridging the Gap in a way, is I want it to be everyone else's platform for pushing the industry forward. So it's not so much for me to talk, it's to listen and to bring people in, and so that we can really talk about, okay, what are some cool things that we're doing in the industry? You know, let's create partnerships and networks to push things forward. I've spoken at some really great events where that was sort of the goal, was let's push the industry forward, and the goal or the hope is that the AEC Disruptors is just that medium, that platform. We welcome anyone that wants to join the conversation to reach out to us. And soon we'll have a landing page that they'll be able to go to. And it's very exciting.
Yeah, very cool. That landing page is the AECDisruptors.com, I believe. Yeah. Very cool. So I got one more question for you, and it's on how generative design and sustainability kind of work hand in hand. But if you want to hear Christopher's answer to that, you're going to have to subscribe to our podcast.
Come follow me.
Well, cool. Thanks so much for joining us on
thanks for
the
having
podcast
me.
and unpacking, I think, what is a really cool topic of generative design.
This has been great. I loved it.
Yeah, thanks so much. And thank you to those tuning into the show. You like what you heard from Christopher today? You can get more. Subscribe to his podcast, the AEC Disruptors, or go to the AECDisruptors.com for more information. If you're interested in how generative design can work for you, reach out to our sponsor, Applied Software, for a discovery call, or visit ASTI.com and let them know we sent you. You can listen anytime by simply going to Apple Podcasts, Spotify, or wherever you listen to podcasts. And also be sure to check out our website at bridgingthegappod.com. Until next time, I'm Todd Wyant, thanking you for joining us on the Bridging the Gap podcast, sponsored by Applied Software. Keep innovating.